Lewis dots can help us understand why certain compounds form in certain ratios. If we look at the example of lithium and fluorine, lithium with 1 valence electron and fluorine with 7 valence electrons, it's easy to see that fluorine is 1 electron short of a full stable outer shell. Lithium will have a full outer shell if it can get rid of one. And so these bond in a 1-to-1 ratio because lithium is happy to give its electron to fluorine and fluorine is happy to accept it. If we were to write what these would look like in terms of a bonding formation, we would show the electron from lithium having left, gone over to fluorine. In terms of an ion, we need to add the brackets and a charge. Lithium having no electrons left, meaning it does have a full outer shell, and it has a positive 1 charge, meaning it's lost an electron. This positive-negative force bonds these two together as opposites attract. This is known as an ionic bond. Another example might be beryllium and fluorine. Beryllium in group 2, which would have 2 valence electrons, and fluorine again having 7. Beryllium looking to get rid of 2 electrons. As this fluorine only is willing to accept 1, you'll note that you'll need a second fluorine to accept the other electron, showing that beryllium and fluorine need to bond in a 1-to-2 ratio in order to satisfy all parties. Beryllium, once having lost 2 electrons, will have a 2+ charge, be stable, and fluorine, full outer shell, and a -1 charge. This +2, -1 bond, which is an ionic bond, makes these two stable and bonded together through the attraction of negative and positive charges. There are some examples where you will see 2 nonmetals, which provide a covalent compound. In covalent compounds, electrons are not transferred, instead they're shared. Both oxygen and fluorine are looking for electrons. Oxygen, which is in group 16, has 6 valence electrons. Fluorine has 7. Sorry, I've drawn 1 extra there. If this oxygen can get close enough to this fluorine, they will feel like they're sharing these electrons. Another fluorine will need to be added so that the other oxygen electron feels like it would have access to this fluorine's electron. If I were to redraw this, this electron from fluorine and this electron from oxygen is going to make them both feel like they have access to it, and it will bond them together. This electron from fluorine there and this electron from oxygen here will also form a bonding pair and have them feel like they have access to sharing that electron. This is a covalent compound because there's the sharing of electrons. These bonds, while keeping these tied close together, are not as strong as these positive-negative bonds.